Hey everyone, and welcome. Today, we're diving into something genuinely new in the world of synthesizers. It's called the adaptive filter slope. And honestly, it's one of those deceptively simple ideas that solves a classic problem in a super elegant way. So let's get right into it.
I mean, just imagine this for a second, especially for all you musicians and sound designers out there. What if your synth was smart enough to adapt its character for every single note you played? What if it just knew what you needed it to do, right in the moment?
Well, that is the big idea behind the adaptive filter slope. It's basically an intelligent system that automatically picks the perfect filter steepness for every note the instant you play it. And that is an absolutely groundbreaking capability.
Now, to really get why this feature is so brilliant, we first have to talk about a classic dilemma. It's a fundamental trade-off that pretty much every synth user has had to deal with forever.
Yeah, it all boils down to this choice right here. You've got your gentle 12 dB per octave slope, which is amazing for those airy, open, harmonically rich lead sounds. But it can make your bass line sound kind of muddy. On the other hand, you have the steep 24 dB slope, perfect for that tight, punchy, aggressive bass, but it can make your high notes sound really thin and, almost sterile. So you're stuck, right? You have to pick one slope for the entire sound patch, which means you are always compromising. Either your bass could be tighter or your lead could sound richer. It's a classic case of one size definitely not fitting all. Well, until now.
And the solution here isn't some complex morphing modulation thing. Nope, it's way cleverer than that. It's a hard, instantaneous switch between 12 dB and 24 dB for each synth voice, right when the note begins. It's a decision, not a slow transition.
So, the big question is, how does it make that decision? You might be thinking it's some kind of complex AI, but the reality is surprisingly simple. It's all driven by just two key things from your performance. First up, the system is looking at where you're playing. The keyboard is basically split into three zones: a low register for bass stuff, a mid-range, and then a high register for all your lead lines.
And second, it's looking at how you're playing. It checks the velocity of every single note, how hard you hit the key, and it sorts it into one of two buckets, either soft or hard.
And we can see the exact default values right here. Anything below MIDI note 48, which is middle C, is considered low. Anything at or above note 72, which is C5, is high. And for velocity, any value over 90 gets categorized as hard. It's these simple thresholds that are the building blocks for this whole amazing system.
Okay, and this is where the magic happens. Those simple inputs, where you play and how you play, feed into this decision matrix. And this gives the filter something you could almost call musical taste. The logic here isn't random at all. It's designed to make the most musically appropriate choice every single time.
But here's the crucial part. This matrix actually changes its logic depending on what filter mode you've picked. So look at that low pass row. For low notes, it defaults to that tight 24 dB slope to keep things from getting muddy. But for high notes, it switches to the airy 12 dB slope. Now, if you switch over to a high-pass filter, the logic completely flips. Now your high notes get that aggressive 24 dB slope for a really sharp cutting sound. See, it adapts to what you're trying to do.
Let's make this super clear with a quick example. Imagine you're using a high-pass filter. You play a high note, say A5, and you play it hard, a velocity of 120. The system checks the matrix. Okay, you're in the high note zone, you're in the hard velocity zone, and you're in high pass mode. The result? Boom. It instantly selects the 24 dB slope, giving you that thin, sharp, acid-like cut exactly where you'd want it, all without you touching a single knob. And what's maybe the most impressive thing about all of this isn't the complexity, it's the simplicity. The way this feature is actually implemented is just incredibly elegant and efficient. And get this, the best part? The additional CPU cost to run this entire smart system is zero. Nothing. Zilch. That's because the synth already has the code for both the 12 dB and the 24 dB filters. This feature just intelligently tells the synth which one to use for each note. It's just a simple choice, not a whole new calculation.
So the whole thing is just seamless. The slope is set once, right when the note starts, so you don't get any weird clicks or phasey artifacts. Every voice is totally independent, so you can play a chord where one note is using a 12 dB filter and another is using a 24 dB filter at the exact same time. And all your other modulations, they work just like they always did. The craziest part? All of this is controlled by one single button.
There's this quote from the design document that just sums it up perfectly. A trivial implementation that produces a musically sophisticated result. I mean, it's the ultimate low-cost, high-reward feature, and that's the hallmark of truly great instrument design right there.